Hi everyone, welcome to another quick session. In this session, we will continue our discussion regarding this biometric authentication. Um, this diagram shows how biometric authentication accuracy is affected by sensitivity settings. It focuses on three key error metrics. So here you can see um, X's um, sensitivity of um, of the biometric. So Access shows the sensitivity, right? And y-axis shows uh, shows the error rate, including both types of errors, right? So false acceptance rate and false uh, rejection rate, right? So false rejection rate is type 1 and false acceptance rate is type 2. We have discussed in our previous video. So, so what is false acceptance rate? When invalid user, invalid user invalid user are wrongly accepted, right? Unauthorized users are wrongly accepted. So lower sensitivity leads to higher uh, false acceptance rate. So that means it's a less strict, more false positive. So false rejection rate, other hand, it is type 1 error, as we can see, and happens when authorized users are wrongly rejected. And as we discussed in previous session, that is not desirable, but it is not still worse than false acceptance. False acceptance when unauthorized users are wrongly accepted. So higher sensitivity causes more uh, more false rejection rate. So too strict, more false negative. So that is still better, but it is not desirable. It's not ideal thing, but it's still better than false acceptance rate. Okay, so in this diagram, what we are trying to understand, the higher sensitivity causes more false rejection rate. So that is higher. This line shows higher sensitivity, right? Okay, so that is the sensitivity line, and lower sensitivity leads to uh, the lower sensitivity leads to higher false acceptance uh, false acceptance rate. So now third thing is that CER, cross error rate, the point where FAR and FRR are equal. So the point It is a key metric for evaluating the accuracy of biometric system. So lower CER, better performing system. So the too low sensitivity, uh, false acceptance rate, low sensitivity leads to higher false acceptance rate, right? So the balanced is FAR, balance sensitivity FAR is equal to FRR. So they meet the both FAR and FRR. If they meet to this point, that is a balanced sensitivity. This is a CER point. Okay, so optimal accuracy we can say. So if we talk about real world example, smartphone unlock, if the device is too strict, it might not recognize your fingerprint. That is false rejection rate. If it is too lenient, someone else might unlock it, right? So the goal is to tune it to the CER point for balance. So false CER is the point where false acceptance rate is equal to false rejection rate, FAR. So that is FAR is equal to FRR. So this is the point. So in simpler terms, it is the sweets. It is the ideal spot, a balance between type 1 error rejecting valid user and type 2 error accepting invalid user. So what does it indicate? It indicates accuracy benchmark for biometric system. The lower the CER, the better the system at distinguishing between valid and invalid user. At CER, the system sensitivity setting is considered optimal. It's not too strict and it's not too lenient, right? So CER means sensitivity is acceptable for type 1 and type 2 error. At CER point, the sensitivity is balanced. Type 1 error is um, type 1 error, false, false rejection are not too frequent. Type 2 errors, false acceptance are also controlled. Uh, it's not perfect. There are still errors, but it's a kind of trade-off between security and usability, right? So that is important point. It is kind of trade-off. So it's not something which we can say it's a perfect or ideal approach, but it is kind of trade-off between security and usability. Okay, so now what we can think that type 2 error should not be a consideration consideration at any point. So type 2 error, which is false acceptance rate, because type 2 means a potential hacker is latent, and this is complete system failure in security contexts. We talked about usability and security. It is kind of, this diagram is showing kind of trade-off, but still we do not want to accept this, that potential attacker could get into the system. This could be a complete system failure in security concept. So in secure environment, you want to minimize or eliminate type 2 errors. So even if it increases type 1 rejections, user trying again and verifying with the FA, it could be a frustrated, but still you want to minimize uh, or eliminate type 2 errors. Type 1 rejection could be frustrating for the user, but it's still acceptable in very highly secure environment. So for instance, if we talk about real world example, bank vault or military access, better to reject a general or officer 10 times by mistake, uh, type 1 than to let in an intruder once, type 2. So for you, it's okay that you reject legitimate or valid user by mistake, but type 1 could lead to a big mess, a big issue, right? So if you let intruder in. So mobile, for instance, mobile phone face unlock focus more on convenience. So some type some type 2 risk may be tolerated if the impact is low. So here is the catch. Type 2 risk may be tolerated if we are talking about very uh, uh, about that system which if that particular system is compromised, the impact is too low. So type 2 error is a security risk. So that means it must be minimized or eliminated. Type 2 can be type 1 can be tolerated, but type 2 should not be. So okay. So uh, so as this graph plots type 2 error, type 1 error, and CER crossover error rate where FAR, FFR meets the meeting point, right? So so now let me tell you one more thing. No biometric system is perfect. Manufacturer must tune the sensitivity. Higher sensitivity, less type 2, but more type 1 error. It's obvious, right? If the system is very sensitive, then uh, we can accept more type 1 error like false rejection rate, and less type 2 false acceptance rate. Lower sensitivity, fewer type 1, but more risk of type 2. So the CR is the point where both error types are equal, so it is used to compare accuracy between system, not necessarily to set the final threshold. So in high security places, as we discussed earlier, sensitivity is increased, so FRR goes up, FAR goes down, but security less. A better security, but it's less convenience. So convenience is not an issue. The issue is false, unauthorized user could get into to the system or to the building, very sensitive building. So in low security or consumer application, for example, a phone unlock, that might accept slightly higher FAR to reduce frustration. So what is the conclusion? Type 2 FAR should be as close to zero as possible in secure systems, secure buildings, sensitive systems, sensitive data. It should be as close to zero as possible in secure system. So this diagram, so now let me make one more clarification about this diagram. So this diagram does not recommend using CER as a goal, but shows how sensitivity tuning affects error rates, how to compare biometric system quality. So this does not recommend you that you should have um, uh, you should have this goal, right? To have where FAR and FRR is equal. So it gives you an idea how sensitivity tuning affects error rates. So how to compare biometric system quality. So I recorded this session very slowly. I was I wanted to make sure that we understand this concept, what CER is, what FAR is, and what FRR is. And you may see this diagram in your CISSP book while preparing exam. So there is a lot of confusion around this diagram. So that our ultimate goal is to when we see this diagram, we think that this is the meeting point, or this is the point, or this should be our goal. But as I said, this is not the goal. It is giving you an idea how the sensitivity tuning affects error rate. So, but again, you can tune your system as per your requirement, as per their sensitivity, how they sensitive, how those systems are sensitive. Based on that, so you can make sure if systems are very sensitive, and very secure system, then we should be as close to zero as a type 2 should be as close to zero as possible in secure system, and false rejection is not desirable, but it could be acceptable too. So that's it about this topic. If you have any feedback or comment, please share in the comment section. Thank you so much for watching this video.